We use linear equations in our daily lives knowingly or unknowingly. Linear equations in two variables x and y is of the form ax plus by plus c equal to 0, where a, b and c are real numbers and a and b are not 0. This condition can be denoted as a square plus b square not equal to 0. It comes under polynomials that has two variables with degree 1. Also, a linear equation in two variables has infinitely many solutions. We can find a few of them by giving random values to one of the variables to find the other, or else by just finding two solutions that can be marked on the xy plane as two coordinate points and can be joined to get a straight line. Also, each solution x, y of a linear equation in two variables ax plus by plus c equal to 0 corresponds to a point on the line representing the linear equation and vice versa. Suppose this box contains some red and blue balls, but we don't know how many are red and how many are blue. The first clue given is that there are 10 balls in the box. Considering x as the number of red balls and y as the number of blue balls, then mathematically we can write it as x plus y equals 10, which is an example of a linear equation in two variables x and y. As a result of such type of equation, we will get many possibilities or solutions. What if we get one more clue? That is, if the number of red balls is double the number of blue balls, then mathematically we can write x equals 2y. So now we have two linear equations in two variables. Let's write them in the standard form. That is, x plus y minus 10 equal to 0 and x minus 2y equal to 0. These two linear equations have the same two variables x and y. Equations like these are called a pair of linear equations in two variables. So, the general form of a pair of linear equations in two variables x and y is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where a1, b1, c1, a2, b2 and c2 are all real numbers and a1 square plus b1 square not equal to 0, a2 square plus b2 square not equal to 0. When we come to its graphical representation, since each of the two linear equations form a straight line, a pair of linear equations in two variables will have two straight lines. But that can come up as three possibilities. That is, they intersect at one point or they will not intersect. That is, they are parallel or else they are coincident. Now, let's work out a problem. Jack tells his daughter, 7 years ago, I was 7 times as old as you were then. Also, 3 years from now, I shall be 3 times as old as you will be. Represent the situation algebraically and graphically. Let the present age of Jack be x and the present age of his daughter be y. 7 years ago, their respective ages will be x minus 7 and y minus 7. Then x minus 7 equals 7 into y minus 7. Converting it as standard form, we get x minus 7y plus 42 equal to 0. Let's consider this as equation 1. 3 years from now, their respective ages will be x plus 3 and y plus 3. Then x plus 3 equals 3 into y plus 3. Converting it as standard form, we get x minus 3y minus 6 equal to 0. Let's consider this as equation 2. So, equations 1 and 2 are the algebraic representation. Now, let's represent this graphically. Consider the first equation, x minus 7y plus 42 equal to 0. Let's find out two solutions, that is 0, 6 and minus 7, 5. Now consider the second equation, x minus 3y minus 6 equal to 0. Let's take 0, minus 2 and 6, 0. Even though we have mentioned them as ordered pairs in brackets, if we tabulate them, it will be easy to plot these points on the xy plane. For our convenience, we have given the scale 1 centimeter equals 2 units on both the x and y axis. So let's consider the first equation. After plotting the 2 points, join them to get the line of the equation x minus 7y plus 42 equal to 0. Similarly, for the second equation, plot the 2 points and join them to get the line of the equation x minus 3y minus 6 equal to 0. Thus, this is the graphical representation, and here the two lines are not parallel or coincident. So, they will intersect at a point which will be got if we extend the two lines on the right side. So, we can conclude that a pair of linear equations in two variables can be represented algebraically as a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where a1, b1, c1, a2, b2 and c2 are all real numbers and a1 square plus b1 square not equal to 0, a2 square plus b2 square not equal to 0, and graphically in the xy plane by two lines which can be intersecting or parallel or coincident with each other.